So, a segment, ray, line, or plane that is perpendicular to a segment at its midpoint is called a perpendicular bisector. So let's break this down. We know that we're cutting something in half because we've got that bisector at its midpoint. If I cut this at its midpoint, both of these are congruent, correct? We know it's perpendicular, so we've got the perpendicular sign here. Okay? So if I label this, for example, A to B, we'll call this C and D. AB bisects CD as a perpendicular bisector. It goes through its midpoint at a 90-degree angle. Both of those sides are congruent. Okay. A point is equidistant from 2 points if the distance from each point is the same. Equidistant, distance. Does that make sense? Equal distance, equidistant. Okay. The distance from a point to a line is defined as the length of the perpendicular segment from the point to that line. So distance from point to line is that perpendicular bisector. When a point is the same distance from a line as it is from another line, then the points are equidistant from the two lines. So if we've got a point, and then we've got two lines, okay, we construct perpendicular bisectors, okay, construct that perpendicular bisector, then these two must be equal to each other. Okay, must be the same distance away from each other. So, perpendicular bisector theorem. This should go in your postulates and theorems. A perpendicular bisector theorem. If a point is on a perpendicular bisector and a segment, then it is equidistant from the endpoints of that segment. So let's draw a picture of what that is. Unfortunately, this will disappear. We know my computer is funky. If you need it, you can ask and we will bring it back up at the end. Okay. Perpendicular bisector. So again, if a point is on the perpendicular bisector, okay, then that point is equidistant from the endpoints of the segment. So instead of lines, let's make this a segment. So those are the same. Okay? If a point is equidistant from the endpoints of a segment, then it's a perpendicular bisector. Okay? If we know the two blue lines are the same length, we know that it forms a perpendicular bisector down the middle. Okay, concurrency of perpendicular bisectors of a triangle. This is important. If the point is in the interior of an angle and is equidistant from the two sides, then it lies on the perpendicular of the angle. Oops, I'm sorry, I'm reading the wrong one. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices. So let's talk about what that means. So we've got a triangle. But now we have to form the three perpendicular bisectors. So we've got one. It's perpendicular. Both of these sides are the same. We've got two. It's perpendicular, so both of these sides are the same. We've got three perpendicular bisector, which means these sides are the same. This point right here in the middle, okay, the concurrency of perpendicular bisectors means that the intersection, this point where all three of those intersect, means the distance from the vertices is all the same. It means these are all the same. So the distance from the dot in the middle to the vertices are all the same. But this is only true for perpendicular bisectors, because we're going to talk about other bisectors in a minute. The name of this perpendicular bisector, this is the kind of vocabulary you will have to know, is called a circumcenter. So I want you to write this in. I do not have it on there. Oh, and I cannot spell anything. Okay, so hold on when Miss Murphy gets her book. This is called a circumcenter. C-I-R-C-U-M, center. Okay? You should write that down right now. I know. Okay. Let's go ahead and do this proof. I know. You guys are all like, Miss Murphy, I hate proofs. I get it. I get it. All right. So first we are given that CP, line CP, is a perpendicular bisector of AB. And we're going to try to prove that CA is equal to CB. So we want to prove that the distance from here to here is the same as the distance from here to here. Okay. So let's write down, the first thing we should always write down is the given. Okay, CP
Can I say the rest?
is perpendicular, no, bisector AB. Keyshawn, what's the reason? Thank you. Okay. What do we know about perpendicular bisectors? It's bisecting AB. What do we know about bisectors? It cuts it in what? A to P is the same as P to B.
Where you get the 2?
What 2?
No, it's
No,
not.
A and P. It sounds like you're saying like
Oh.
A and 2.
The distance from A to P is the same as the distance from P, B. Okay, so AP is congruent to PB, because what do we call this? What is this point right here? What's P? It's not, the bisector is CP. What's P? Midpoint. Definition of midpoint.
Oh my God.
Okay, so let's look. Does anybody see 2 triangles here?
Yeah.
Okay. Do we have anything in there that could possibly be reflexive?
Yes.
What?
CP.
CP is congruent to CP by reflexive. Okay. So, if these two, so if we now have CP is congruent to CP, all right, we need another angle or another side. What is this thing called that we talked about, that we learned today? What do we know about perpendicular? They make 90-degree angles, so we have another angle. So we got to write that down. We have to say that angle APC equals 90 degrees, and angle CPB equals 90 degrees by definition of perpendicular. And now we can say they're congruent to each other, right? Angle APC is congruent to angle CPB by definition of right angles. Okay. So now, how are those triangles congruent to each other? Side angle side. Triangle APC is congruent to triangle CPB by side angle side. Okay. So what do we know about CA and CP? By what? Nice. Okay. You ready? I'm going to flip it over. So in the diagram, yes, there's a typo. Do you guys see on your typo, it should say that they're congruent to each other, not equal. It says under prove that they're equal. Okay. All right. Let's look. In the diagram shown, it's perpendicular. What does it say? I'm sorry, my board's messed up. Okay. Diagram shown, EC is the perpendicular bisector of AB. And AF is congruent to BF. So what do I always tell you when it gives you information? We're supposed to do what to that picture? Mark that picture up. Okay. So EC is the perpendicular bisector of AB. So EC is coming through, so we know both of these are right angles. Okay. We also know that AF, A to F, is congruent to BF. Explain how we know AC is equal to BC. How is AC equal to BC? Definition of a midpoint. Is MP okay for midpoint? I'm just abbreviating. Explain why F must be on EC. Why must, this line doesn't show that it continues, but if it continued, why must it go through F? Yes, Cole.
EC is a rect and it keeps going forever.
So EC keeps going forever. We know two things. We know that angle BCF equals 90. And we know angle ACF equals 90. Why do we know that? If you cut a line perpendicularly, how many right angles does it form? 4. Perpendicular lines form 4 right angles. Okay? And we know BF and AF are congruent. Did we learn anything today about that? If a point is equidistant from the endpoints of a segment, then it is perpendicular bisector. Perpendicular bisector converse. And perpendicular bisector converse. So first we proved that it was perpendicular. So we know that it forms 4 right angles. So we know it has to be perpendicular. Then by the perpendicular converse, if those two are congruent, it must continue and go through. It must be a bisector. Okay. Let's do one more. Mr. Van Horsen, was there not enough 5.2Bs? All right, I must have messed up the copy machine somehow, so we'll just do A. All right. BD is the perpendicular bisector of AC. What does that mean for those two things? What do I got up here? This cuts it in half. That means these two, C to D and A to D, are what to each other? Congruent. Therefore, 3, oops. Therefore, 3x plus 14 equals 5x. If it is a perpendicular bisector, both sides must be equal to each other. That's a new theorem we learned today. Okay. Subtract 3x from both sides. 14 equals 2x. Divide by 2. X equals 7. Okay, so, Mr. Van Horsen, can I see your copy? I just want to do one of the problems from 5.2b. Okay. No, I don't. Pretty much the same thing. Okay, so 5.2b, I had some extra proofs on there. Maybe I'll save those for the review. I think you'll be okay. Thank you. All right, ladies and gentlemen, what